All right, let's dive right into this explainer and unpack a truly fascinating development in the world of global tech infrastructure. Today, we're looking at how China Telecom Quantum Group built a quantum computing platform that, structurally speaking, no Western cloud service can currently match. It's called the Tianyan Quantum Cloud, and it just crossed a staggering milestone of 50 million visits. We're going to break down exactly how this happened, the tech that's powering it, and what it all means for the future of global computing.
There is a quote from the sources that really hits the nail on the head here. It is not Amazon, it is not Microsoft, it is not Google. And that's incredibly compelling, right? Because we are so conditioned to associate massive cloud scale directly with Silicon Valley giants. But this platform, it's run by a Chinese state telecom company. And right now, it's processing over 4 million experimental tasks for users logging in from more than 60 countries around the planet. While so many frontier quantum projects are locked behind tight research partnerships or invite-only access, this is something literally anyone in the world can just walk up to and apply to use.
Okay, moving into Section 1, the 50 million milestone, where we look at remote quantum access.
What we're really talking about here is remote access to actual physical quantum hardware. We aren't talking about simulators running on classical computers just pretending to be quantum machines. We are talking about actual quantum processors sitting in data centers answering requests from across the globe over the internet. And the growth trajectory is just staggering. The platform only launched in November 2023. By December 2024, it hit 12 million visits. Early 2026, 37 million. And by the summer of 2026, it blew right past 50 million visits. This isn't your typical slow, organic growth. This is a platform going completely vertical in a matter of months.
So what's actually driving all that traffic? Well, initially, it was the Tianyan 504. This is a 504-qubit superconducting quantum computer. It's powered by a chip called Shaohong, which was developed in partnership with the Chinese Academy of Sciences and Quantum CTech. When it first debuted, Chinese researchers reported that it rivaled international platforms on some absolutely crucial performance metrics, specifically qubit lifetime and readout fidelity. Now, if you aren't super familiar, those are highly technical measures of how reliably a quantum chip can actually do useful work before its delicate quantum state just collapses into noise.
Which brings us to Section 2, two technologies, one cloud, a genuine world's first.
Things got absolutely wild in June 2026. China Telecom didn't just add another superconducting chip to their network. No, they claimed a world first by connecting an entirely different kind of quantum computer to the exact same platform. On one hand, you have superconducting hardware, like the Tianyan 504, which requires extreme cooling, getting down to near absolute zero. But on the other hand, you have the new Tianyan P2000. This is a photonic quantum computer. It operates at room temperature by encoding information directly into particles of light, or photons. It uses the Jiazhong 4.0 optical architecture from the University of Science and Technology of China, and its landmark results were famously published in the journal Nature. Now, both of these totally distinct technologies are available under one single login.
The numbers behind this new photonic machine, the P2000, are literally mind-bending. It can control up to 2,682 photons simultaneously. In one demonstration, it finished a calculation in just 29 microseconds. Researchers estimate that the exact same calculation would take the most powerful classical supercomputer on the planet 16 billion years to finish. Think about that for a second. 16 billion years, that is older than the universe, versus a fraction of a second.
But hey, we do have to keep our feet firmly on the ground here. This 16 billion year gap applies to a highly specific task called boson sampling. It's a benchmark task used to demonstrate quantum advantage. It does not mean this machine can suddenly outthink a classical computer on everyday problems or general tasks. It's a very narrow but highly significant laboratory milestone.
I love this analogy from the sources. They aren't betting on one horse, they're building an entire stable. It perfectly captures the strategy. By integrating both superconducting and photonic systems into one cloud, they are making a massive strategic hedge. The entire global scientific community is currently racing toward fault-tolerant quantum machines, but there's a lot of real uncertainty over which hardware approach is actually going to scale best. Offering both simultaneously lets researchers test both approaches on the exact same infrastructure.
Let's move to Section 3, the quantum access gap, centralized versus fragmented.
We really need to see how this centralized approach contrasts with the rest of the globe. But first,
what are people actually doing with these machines? Well, it's not just isolated science experiments. The platform is being used for real-world applications right now. Researchers are studying molecular structures for drug discovery. Businesses are tackling complex machine vision optimization and spectral computation, plus analyzing graph data. And incredibly, access to all of this is currently free, pending a straightforward application review process.
Now, contrast that with the Western landscape. It's incredibly impressive for sure, but it is highly fragmented. IBM's Qiskit is an absolute titan. We're talking over 600,000 users and 3 trillion circuits run since it launched in 2016. Google has its powerful 105-qubit Willow chip, but access there is largely curated through invite-only research partnerships, like with the UK's NQCC. Then you have Amazon Bracket for pay-as-you-go access, Microsoft Azure, and amazing specialized startups like IonQ, Rigetti, and Pascal, who are deploying neutral atom systems in places like Europe and with Saudi Aramco. But as a user, you have to navigate multiple vendors, completely different pricing tiers, separate documentation, and totally different sign-up flows.
So all of this builds into a very real geopolitical reality. The unified Chinese approach relies on a state-backed platform that centralizes the whole shebang. It pushes aggressively for volume. Think about it from the perspective of an outside researcher. For a student in Nairobi or university lab in Sao Paulo, they don't have to guess which fragmented ecosystem to invest their limited time into. Tianyan just removes that decision entirely with one application and one login.
Which leads us to our final section. Section 4, Platform Power versus Raw Compute.
Okay, it is absolutely vital that we separate the hype of website traffic from the reality of raw laboratory milestones, because, they are not the same thing. We are essentially comparing two completely different types of leadership here. On one side, Tianyan has clear platform ecosystem dominance. Those 50 million visits represent a massive shared knowledge base. But on the other side, Western companies still maintain leadership in raw compute and the critical engineering challenge of error correction. High platform visits do not automatically equal technological supremacy.
To be completely objective, the race for raw compute is far from over. Western labs are producing genuine, massive breakthroughs. IBM has a highly credible decade-long roadmap toward large-scale error correction. Google's Willow chip demonstrated that adding more physical qubits can actually reduce error rates rather than compound them, which is a huge deal. And companies like Atom Computing are setting records for logical qubit entanglement. These are fundamental engineering victories that Chinese labs just haven't publicly replicated at the same scale yet.
But here is exactly why Tianyan's visit numbers matter so much. Ecosystems compound. It's a feedback loop. You start with unified, easy access to diverse hardware. Then, researchers use it and publish papers citing the platform's data. That naturally builds out the documentation and creates community trust. Because of that trust, the next wave of new users defaults to the platform with the most momentum. 50 million visits isn't just some vanity metric, it is an accumulating base of shared knowledge that becomes increasingly difficult for fragmented competitors to displace.
So I want to leave you with this final provocative thought. As we look at the years ahead, is the future of quantum computing going to depend more on who achieves the highest raw qubit counts and laboratory milestones, or will it be dictated by who provides open, centralized, high-volume access to the world? It's a massive open question for the future of our global tech infrastructure. Thank you so much for joining me for this explainer, and hey, please make sure to subscribe as we continue to track this fascinating global race.